All right, today we're not just going through some physics concepts. No, we're cracking a case. We're launching a full-blown investigation into the strange, misleading testimony of your very own senses. And we're going to start right at the scene of the crime.
So, picture this. You're at a park on a chilly day. You sit on the metal part of a bench and whoa, it feels absolutely freezing. So you shift over to the wooden slats and it feels, well, a lot warmer. But here's the thing. If you pulled out a thermometer, it would tell you they're the exact same temperature. So what on earth is going on here? This isn't just a weird feeling. It's our first major clue.
You know, the first rule of this whole investigation is super simple. Do not trust your primary witness. And in this case, that's your own sense of touch. It's a known liar. To get to the truth, we have to ignore what we feel and start following the actual physical evidence. Every good mystery needs a lineup of suspects, right? Well, in our case, there are three concepts that everybody, and I mean everybody, mixes up: temperature, thermal energy, and heat. Trust me, they are not the same thing, and figuring out who's really responsible for the crime means telling them apart. First up in the lineup, we have temperature. Now, this suspect isn't really a measure of hotness in the way you might think. Its MO is actually just to measure the average speed of all the little microscopic particles in something. So if the particles are wiggling around really fast, that means a higher temperature. Slower wiggles, lower temperature. That's pretty much it. Next up, we've got thermal energy. This one's all about the big picture. It doesn't care about the average speed of the particles. It cares about the total combined energy of all of them. So yeah, the amount of stuff you're dealing with, it matters a whole lot. And this right here proves that our first two suspects are totally different characters. Think about it. A cup of boiling water has a super high temperature, right? Its particles are moving incredibly fast. But a swimming pool, even though its temperature is much lower, has way more thermal energy, just because it has trillions upon trillions more particles in it. And here's our final suspect: heat. And honestly, this is the real game changer. See, heat isn't something an object has, it's something that happens. It's the process of energy moving from a hotter place to a cooler place. It is energy in transit. That's the crucial detail.
Okay, so if heat is the transfer of energy, then how does it actually get from point A to point B? To solve this, we need to follow the clues and figure out its methods.
In the curious case of our park bench, the method is something called conduction. This is simply energy transfer through direct contact. So when you sit down, your body, which is warmer, starts transferring its energy straight to the cooler bench just by touching it.
And this, right here, is the major breakthrough in the case. The whole deception is finally revealed. Your skin is a terrible thermometer. It doesn't actually measure temperature at all. It can only detect the rate of heat flow. That cold feeling you get, that's just the sensation of energy leaving your body really fast.
Okay, so if what we're feeling is just the rate of energy leaving us, that leads to another question. Why did different materials pull that energy away at such different speeds? To answer that, we need our next piece of evidence. I call it the thermal sponge clue.
Now, the official scientific term is specific heat capacity. But a much better way to think about it is that some materials, like water, are like these giant thermal sponges. They can just soak up a ton of energy without their temperature changing all that much. And other materials, like metal, they're more like thermal rocks. You add just a tiny bit of energy and their temperature shoots right up.
This chart is crucial evidence. Just look at water. It's a massive sponge. That's exactly why the ocean takes all summer to warm up. Wood is a pretty decent insulator, so it's kind of like a medium sponge. But metal, it's a rock. It can barely absorb any energy, which makes it an expert at passing that energy away from you. And you already know this from experience. I mean, why does pizza cheese, which is mostly water, burn the absolute daylights out of the roof of your mouth while the crust is totally fine? They both came out of the same oven. It's because the cheese is a heat sponge, and it's holding on to way more thermal energy just waiting to dump it all into your mouth. But hold on, there's one more twist in this investigation. A final piece of evidence that seems to defy all logic. See, sometimes you can add energy to something and, well, nothing seems to happen at all. This is the secret of the hidden energy. Just think about a glass of ice water. As that ice melts, you can stick a thermometer in there and it will just sit there, steady, at 0 degrees Celsius or 32 Fahrenheit. It doesn't budge. It stays right there until the very last sliver of ice is gone. Now this should really bother you. We know that heat is just energy flowing from the warmer room into that colder glass. So, if energy is being added, but the temperature, the particle speed isn't going up, where is all that energy going?
And here it is, our top secret file, latent heat. That energy isn't lost at all, it's just being used for a completely different job. Instead of making the particles dance around faster, it's being used to break the bonds that hold them together as a solid, turning ice into water. It's hidden energy, doing the quiet work of changing the state of matter itself.
So, with all the evidence on the table, the suspects identified, the methods uncovered, and all the hidden clues finally revealed, we can officially close this case and develop a new, much sharper intuition about the world.
And so, the verdict is in. The metal bench feels colder because it's an amazing conductor, a total thermal rock. It rips energy away from your body at a shockingly high rate. The wood, on the other hand, is a poor conductor, more of an insulator, so it pulls energy away from you much more slowly. You were never feeling temperature, you were feeling the speed of a thermal robbery.
So here it is, your new detective toolkit for understanding how things really work. Just remember, temperature is just particle speed. Heat is the movement of that energy. Your hand is a terrible thermometer. Some things are heat sponges, and some energy gets hidden away to change what a substance is.
If you take away just one thing from all this, let it be this thought. Temperature is just the speed of the dance. Thermal energy is the power of the whole crowd. And what your skin feels, well, that's just how fast that crowd is pulling you onto the dance floor. Case closed.